Hey there, science fans! Have you ever wondered how many ways you can arrange your favorite toys on a shelf? Or how many different ice cream flavors you can combine for a delicious treat? Well, get ready to explore the exciting world of permutations and combinations. These mathematical concepts help us count all the possibilities in different situations. It's like being a detective of arrangements. Let's say you have 3 friends coming over and you want to line up to go to the park. How many different ways can you line up? That's a permutation. But what if you're choosing toppings for a pizza? The order doesn't matter, right? That's a combination. Don't worry, we'll dive deeper into each concept with fun examples. Get ready to unlock the secrets of counting possibilities. We'll learn how to use these mathematical tools to figure out everything from the number of ways to arrange books on a shelf to the possible combinations of lottery numbers. So put on your thinking caps and let's embark on this exciting mathematical adventure. Imagine you're at your favorite ice cream shop and there are 3 flavors to choose from: chocolate, vanilla, and strawberry. You want to try all 3, but in what order should you get them? Let's find out. If you choose chocolate first, you have 2 flavors left: vanilla and strawberry. If you choose vanilla next, you only have 1 option left: strawberry. And if you choose strawberry next, well, you've tried all the flavors. So, for the first scoop, you have 3 choices. For the second scoop, 2 choices. And for the last scoop, only 1 choice. To get the total number of different orders, we multiply the possibilities for each scoop. 3 times 2 times 1 equals 6. That's right. There are 6 different ways you can order those 3 delicious flavors. This is called a permutation, where the order of the items matters. Now let's talk about combinations. Imagine you're playing the lottery, and you need to choose 6 numbers from 1 to 49. Does the order in which the numbers are drawn matter? Nope. As long as you have the winning numbers, it doesn't matter if your numbers come up first, last, or in between. Let's say your lucky numbers are 7, 12, 22, 35, 41, and 48. Whether these numbers are drawn in that exact order or any other order, you still win. In combinations, we only care about the group of items, not the order they're in. Calculating combinations can be a bit trickier than permutations, but don't worry, we'll learn some cool formulas later on. For now, just remember that combinations are all about choosing groups where the order doesn't matter. Remember our ice cream adventure? What if you could choose the same flavor more than once? This is called a permutation with repetition, where you can repeat items. Let's say you're super hungry and want 3 scoops of ice cream again, but this time, you can choose the same flavor multiple times. For each scoop, you still have 3 choices: chocolate, vanilla, or strawberry. So, for the first scoop, you have 3 choices. For the second scoop, you also have 3 choices. And for the third scoop, you guessed it, you still have 3 choices. To find the total number of possibilities, we multiply the number of choices for each scoop. 3 times 3 times 3 equals 27. That's a lot of ice cream combinations. Section 5. Picking a team. Combinations with repetition. Let's explore combinations with repetition. Imagine you're a coach forming a basketball team of 5 players, and you have 10 equally skilled players to choose from. You can choose the same player for multiple positions if you want a really strong team in a particular area. Since the order we pick the players doesn't matter, this is a combination. And because we can choose the same player more than once for different positions, it's a combination with repetition. Calculating combinations with repetition can be a bit more challenging, but we'll learn some handy formulas later on. Just remember that in this type of combination, we're dealing with groups where the order doesn't matter, and we can repeat items. Section 6. Permutations versus combinations. What's the difference? Okay, science explorers, let's recap the key difference between permutations and combinations. Permutations. Order matters. Think about lining up for ice cream or arranging books on a shelf. Each different order creates a new permutation. Combinations. Order doesn't matter. Think about winning lottery numbers or choosing toppings for a pizza. It's all about the group of items, not their order. Remember our ice cream examples? Choosing 3 different flavors and the order you eat them in is a permutation. But if you could have 3 scoops of any flavor, it's a combination because the order doesn't matter. So the next time you're faced with a counting problem, ask yourself, does the order matter in this situation? If the answer is yes, it's a permutation. If not, it's a combination. Section 7. Calculate like a pro. Now that we understand the difference between permutations and combinations, let's learn some cool formulas to calculate them like math wizards. Permutations, without repetition. The formula is n factorial divided by n minus r factorial, where n is the total number of items, and r is the number of items you're choosing. The factorial symbol means multiplying a number by all the whole numbers less than it down to 1. For example, 5 factorial is 5 times 4 times 3 times 2 times 1, which equals 120. With repetition, the formula is simply n raised to the power of r, where n is the number of choices for each item, and r is the number of items you're choosing. Combinations, without repetition. The formula is n factorial divided by the product of r factorial and n minus r factorial. This might look scary, but it's just a fancy way of saying we're dividing the number of permutations by the number of ways to order the chosen items. With repetition, the formula rr plus n minus 1 factorial divided by the product of r factorial and n minus 1 factorial is a bit more complex but still manageable with practice. Don't worry too much about memorizing these formulas right away. The key is to understand the concepts behind them. With a little practice, you'll become a calculating pro in no time. Section 8. Keep on combining and permuting. Congratulations, math superstars! You've unlocked the power of permutations and combinations. You've learned how to differentiate between these 2 essential counting methods and even tackled some cool formulas to calculate them. Remember, permutations are all about arrangements where order matters, while combinations focus on groups where order doesn't matter. Whether you're figuring out how many ways to line up for a game or exploring different flavor combinations, permutations and combinations are here to help. So keep those brains buzzing with possibilities. Challenge yourself to find permutations and combinations in everyday life. The more you practice, the more confident you'll become in the exciting world of counting.